Yo, good morning, happy Friday, and so on. I'm just gonna jump right into it. We're working on activity texture. We're looking into ways to optimize it. So pretty much trying to offload a lot of the work on the CPU to the GPU. Because we're getting some. If we have a lot of objects moving, the FPS is quite affected, but that's without threading. We haven't done anything with that yet. But we're gonna see what kind of performance we get if we instead rely on where do we have it? This one. So right now it's not that optimized. We're just trying to get it to work. So it's pretty much going to be entity has a get mesh here, and then we're going to call update activity here. We're probably going to do this one. So occupy entity. We calculate which terrain patch it's in, and then we render it here. So we just take a command buffer, set render target, and then we draw mesh. And currently we're just trying to get this to work. I don't think we tried it yesterday. Wonder if we need to do... Yeah, we'll see. So pretty much right now, for each entity, we create a command buffer, but we're going to optimize this. If we can get it to work, then we can also optimize it eventually. I want to be able to visualize this as well, so we're going to do, let's quit. Yo, what's up, Harry-O? I have something for you. I'm waiting. Oh shit. Uno sekunda. Fuck, dude, is this yours? Very nice. Let's see. That is beautiful. Let's see. How is the performance? Okay, sick. Good morning, Geralt. Okay, this looks very good. Let's see. Queue for render. So this is when you bring it from world position to patch position-ish. Right. Chunk. Okay. Okay. Oh, fucking beautiful, man. Do we have... Don't we have a shader as well, or what material do we run with? Okay. No custom shaders. Okay, interesting. Very interesting. Entity... I wonder... Yeah, I could probably do some nice things with instancing eventually, right? Just to optimize it a little bit further. Fuck, very nice. I wanted to check one thing. Chunk. Yeah, what's up, Catboy King? Yeah, what's up over on YouTube? I'm not gonna try and pronounce that name. Hope you're having a wonderful Friday. It's one thing I want to figure out here. It's that projection matrix. Okay, so it's the projection matrix that does the... Okay, so this one pretty much does the heavy lifting for transforming it into texture space, I guess. But... Or am I... clearing the target? Yep. Does it matter what... Actually, ortho... Like, would you like to base... Oh, yeah, we base this one on size. Yeah, that's true. Minus 100 and 100. Is this far and near clip plane? I haven't... Yeah. Beautiful. Let's see. Okay, entity. Map. So this is pretty much my terrain base. We have chunks. Yeah, having the command buffer in terrain base is probably best. List of entities. This is where I wonder where I want to go. So here we pretty much do... Yeah, check which terrain patch it belongs to. Clear. Okay. Okay, beautiful. That's basically what we want to do. We're halfway there, I guess. We do this shit here. Maybe we can wait with that. I have to say, this is very nice. The only thing that still bothers me a tiny bit is... this is not fully decided though, but in our activity texture right now we have 4 byte values and 1 float value. The timestamp, I'm just thinking of how we could possibly push all of that into one texture. Yo, what's up Calvino? Good morning, good morning. Doesn't have to be one texture, that is true. You can write to multiple textures with one draw call. Is that so? Really? Huh. Okay, then we pretty much have it. Okay, I'm just trying to figure out... Here we go, SV target 1, SV target 2. Yeah, definitely gonna have to check into that eventually. Let's see. Damn. Okay. Okay, this is pretty fucking insane, honestly. So let's see here. Terrain base. Entity, let's clean this up. Or actually, no. Let's get it in place so we can try it first and foremost. How should I make it work with my... Okay, let's do this. Environment, terrain material. Let's create a temporary terrain material here that we can test with. Functional shaders. Yeah, terrain activity data. I'm gonna have to rework this a tiny bit again, and that's okay. Debug shaders. Probably want to move this one, but whatever. Let's do this. Terrain activity debug shader. Yo, what's up, Klaus? Input UV terrain activity data size. This one we need to send in, but that's pretty much it. And then this one, I guess, but... yeah, let's clean this one up. Grid line width. Okay, and then if we take a look at terrain activity data HLSL here, so we went from texture to compute buffer to texture. That's okay. What's up, hard dev? Nothing is set in stone still, so terrain terrain activity data. What I'm gonna do here is we're gonna add a I'm gonna do, let's keep those. Solution. So texture 2D, that's how we do it, right? Texture 2D sampler state. Oh, fuck it. Activity output. Yeah, this one, I wouldn't care about this one right now. Let's see, grid line width, and then we do this. Where did I put texture 2D? Oh yeah, here. Never mind. Terrain activity data. Yes, here we set texture 2D. Terrain activity texture. Point clamp, I think. This we can still return, so terrain activity data what's up to 2 apps. And for now, what I'm gonna do is let's worry about this one later. Let's just do terrain activity data dot direction is equal to data XYZ. Yeah, let's just do this. So we're gonna read using this one instead. So terrain activity debug shader. We get a grid. We still we still need to have the size, but we have it here. Yo, Toto Apps, also sorry I did not join the other live streams, I just beat cancer. No problem at all, my man, and congratulations. So, let's see here. Yeah, we're moving to texture instead of structured buffer for this one. Anything else? Terrain activity data size. So. Okay, let's see here. There's so many things that needs to be done. Queue for render. I'm wondering. Okay. Okay. Properties. Okay. What this activity map does. Let's see if we can. I don't know if we can play currently or if we have any issues. But we're basically gonna have a lot of data in our terrain, and we just want to. We want to be able to store a lot of real-time data for our terrain, and that's our activity texture is like movement on the terrain, basically. So this right here, we're just trying to optimize it with Herio's implementation of it, which seems to be very good. Just trying to add it to my system in the best possible way. Okay, so there's so many things I'm not entirely sure about. So if we go with this solution, we're gonna have to keep track of entities that are currently on a terrain patch. Or that is not exactly true. We need to keep track of entities that are currently on a terrain patch and has moved. Okay, but for now, let's do it like we currently do it. Occupy entity, and then we call render. Render. And we create a new command buffer. No. Let's. Do we want to have? Yeah, we just want to have one of this, and then we reset it every frame. So when we call render down here, we actually want to send in the command buffer as well. Let's rename this one activity material. We're probably... Do I want to use this one now? Yeah, probably want to use it in the future, but... Set render target. We're gonna restructure and optimize it soon. I just want to make sure. Draw mesh, get mesh, entity transform local world to matrix, and then activity material. So what we could do here, which I think is very nice, is this part right here. I love it. Matrix, set projection matrix. Yes, one of these we want to create. Fuck. I wonder. I have so many thoughts going on right now how I want to structure this, but this seems to be such a very nice way to do this. So I wonder if we want to do. Previously, when we did height alteration of the terrain, we did it by blit. We could probably do it something very similar as we do here, which means that we could use these things for a lot of stuff, or we could use these things for multiple different purposes. So when I define a matrix here right now, activity texture, what do we do? Matrix 4x4. I wonder if we want to call it data projection. And we do something like this. hue matrix. Clear render target. Yeah, what kind of persistency are we looking at with render texture as well? I don't know. And then we draw the mesh. Currently, okay, we're gonna use a custom material here because it would be very cool to do some custom stuff eventually. Material property blocks, yes. But okay, so if we do, let's see, activity material as well. What did we do with this one? Activity material, we instantiated it as activity output. Do we need these? No, we don't. No. And one more thing, we do have set material. Create new. I just want to set, let's see here. So for now, we're gonna use terrain activity debug. I want to set this one, and this one. So it's texture, activity texture, set vector, be able to quickly test this. Activity output. So here what we want to do now is position OS, fuck these, and here we just do what is my go-to? We do how do we send a rigid body? Don't we have that one? Ah, yeah, that's true. Some of these might not have a rigid body. This one, there's a lot of things we want to clean up eventually, but for now we can do bounds. Eventually we want to have a clear here as well. Ah, fuck, this is very ugly right now, but that's okay. Dynamic entity. Okay, so for each dynamic entity we call update, and this is where we call occupy, and right now we just figure out which terrain patch and then we render it instantly. One sec. Definitely want to wait with this one. Oh, something like this. Let's see what we have. Okay, something like this. Command lerp. Okay, now we don't have any errors anymore, so let's take a look at terrain activity debug shader. There we go, 0.002, and let's add this one as a default terrain material. Bam. So what should we have now? We should have a grid, but I don't know if we're gonna show that much. Okay, this is not the correct grid. Why not? Okay, yeah, we don't get I get a feeling that these aren't properly set, but they should be. Terrain activity texture. And terrain activity data size. I find it very weird that we don't even get a good grid here. Okay, so this one isn't properly set. Why not? Oh. Okay. don't care about these right now. Okay, beautiful. Do we have... Oh, what the fuck? Interesting. Okay, so something. We're rendering some... Ooh. Oh. Projection matrix... possibly fucked. Most likely fucked. But this is pretty cool. Okay, so if we move over to one of the other patches, do we also get something down in the corner? Or not? No, we don't. It's a step in the right direction, at least. I guess. Seems to be working. Set render target, activity texture, identity, data projection matrix. This one I'm a little bit worried about. Get mesh. Oh no. Which one? Map chunk. Entity. We don't really care about quad. Projection matrix. I need to take a look at ortho. Left side x coordinate, right side x coordinate, bottom, top. I wonder. Mr. Croy, I'm so jealous of the fact that you can code. I want to learn this too, but it's hard. I still think it's quite hard, honestly. I just keep at it. Oh yeah, I'm still wondering what you can do with the activity map for your game, or is it just made for fun? Kind of confused after joining in. Yeah, sorry, I didn't really explain that very well, but we can utilize this activity map for a lot of things. Mostly visual. So for instance, if we have a pool of water and the character or some entity runs in it, we want to create ripples. Or if we have a field of grass and a lot of entities run over the field of grass, we want to bend the grass in a dynamic way. You could have snow as well. If we have a snow landscape, we want to render trails for where entities have walked and stuff like that. Hopefully that finally answers the question. I'm sorry I didn't answer it earlier. But okay. So I'm thinking that my ortho matrix might not be correct. Where do we have it? I wonder. Position here is pretty much in the it's in the middle of the plane in this case. I wonder if we want to go. I wonder what this would give us. Because I think we're situated at the edge of it. But I'm not sure. Okay, a lot of things can be wrong here. Okay, so for this one it works. The projection matrix is fucked. But now it seems like we're at the center at least. Although I wonder what we're currently seeing here. Okay, and here it doesn't work. So as soon as we go positive Z, also Puka randomly got seg faults in my Go code. That doesn't sound very good. Okay, what the hell happened here? Yeah, we actually have it's the view matrix and projection matrix in one, is it? Do we need... Now we're doing minus 100, 100, so we shouldn't be... We don't need to move this one up or down, I don't think. But what the fuck? And if we set these correctly... The transformation from object space to clip space here should be okay. That's what I'm hoping for at least. Oh, are we? Yeah, we're out of bounds, but I want to see characters here. One prefab. I wonder. Get component in children. It should be doing. Yeah, we should be getting the correct one here, I think. I just want to make sure. I'm gonna go. Okay. Okay, now we're using the correct mesh at least. But we're located. Projection sucks. I wonder if it's because this basically looks too small. What the fuck? I don't know. Yeah. Could be so many things as well. Could be... I'm starting to think that it might not be this one, but rather entity transform local to world matrix. Could actually be this one now when I'm thinking about it. Or yes. Yo, what's up, Harrio? Yeah, it has to. It's not resolution, it's dimension. Yeah, yep. Yup. Now we should get a little bit of a better result, hopefully. We still are a bit off, but I think I know why now. Or actually two things. Two things one thing I know for sure. I think we need to offset it. And second of all, I wonder why. Yeah, exactly. We need to do size, minus size, minus 0.5 size, and plus. But I also wonder why do we only get it on this one? Isn't that a little bit weird? Okay. I guess we have T-pose mesh as well. A little bit of issues here. Oh, do we have a little bit of a problem between patches again? Fun. Nah, never mind. I know what it is. But okay, this is pretty cool. Yeah, right now we just take the patch that is... So we take the bounce of the object and then we take the patch that is at the minimum point of the bounce, I think. So we don't take multiple currently, but that's okay. Although... we're getting the... we're getting the T-pose mesh, so unskinned, which I wonder about. Shared mesh. Character mesh. We want to get... Can't we... Oh, do we need to do... What if I can draw a render, by the way? Is this... Is this better than doing draw mesh? Yeah, draw render might work. Yeah, let's give it a try. But I also wonder why... Fucking... Render feels... let's just try it, see what we have. Get mesh, so let's do... Entity. Render test. Yeah, let's just try with this one. Terrain patch. Entity. Draw renderer. Material. Oh, we don't care about local to world matrix then. Let's try it. But so like in a use when we use it like we're currently doing, why would we, like, I wonder if draw render depends on if it works. Oh yeah, never mind. I need to do, let's do a check here as well. If return, like when we have it, when we do it, or for the use case we're currently using this, wouldn't it be preferable to always do draw renderer instead of draw mesh? Draw mesh, I could see if you have uninstantiated meshes and stuff like that, but I don't know. This seems to work, doesn't it? Would love to be a the grid doesn't really, we're having a little bit of offset between grid and character here as well. I wonder why. I might know why. Terrain activity data size. Harry, I'm just used to draw mesh. Yeah, same here. Or like when I've done stuff previously, it's has always been with draw mesh. Not too many things. But like when we have instantiated objects like this, I wonder draw renderer. But let's see here. Oh yeah, why are we getting the wrong? Yeah, it's probably because we want to go resolution -1 here, or I wonder if that's the case. Let's see. Pretty fucking cool. Yeah, so I wonder if to calculate grid best, I wonder if it's just float 2. I wonder if it's just that I've failed in the size. No. Why doesn't this match with? I wonder why we're not getting... Maybe this is okay. But why the fuck is this resolution wrong? Or is it actually when we read? Oh, yes it is, yes it is. This grid is 100% correct. Yeah, it works with this one. It's when we read back the values. Fuck yeah. When we do get terrain activity data from texture input UV, we need to do UV, we're going from 0 to 1. We need to offset it by I wonder if we need both scale it and offset it. We need to scale it. Can you set the texture rest down instead? I assume you're going from 128 to 127. I think the texture is 128 times 128 pixels. So going from 0 to 127. The problem is the... Let's see here. The problem... Or it's not really a problem, it's just we need to rescale it a tiny bit. We have, how should I paint this? If this is our texture, we want to read from let's go with 4 easier. We want to read from, so when we have a UV of 0 and 1, we actually start at this point and go to these points. We actually want to scale it so that our 0, 0 is located here and that our 1, 0 is located here. So we want to scale it by 1 divided by res minus 1 maybe, and then offset it by 1 minus res times 0.5, something like that. I've done this so many times I should remember it by heart, or I should actually have it somewhere. Debug. Is it enough to offset it? No. You probably want to avoid scaling if possible, as you will need to change ortho matrix as well. Yeah, but what I'm wondering here... Yeah, that is true. We have a readback issue, first and foremost. As like when we read the texture values, we read them a little bit wrong. But yeah, that's true. We might need to change the ortho matrix as well. Okay, first of all, I want to fix okay, let's try and do UV fixed. UV times something. I'm just gonna do 1 plus 1 divided, or 1 divided by interactive data size. Can we do it like this? Hario, how many cells are there in a chunk? When you divide by res plus 1, it changes the texture res you'd expect. So before messing with that, it's 128 times 128 right now. So we go from index 0 to 127. And this is just for reading it back, pretty much. I just want to convert a... Yes, now we have them. Okay, this is good. Oh fuck, no it isn't. We're still getting... Can we do this? Try changing your render texture resolution to be -1 or +1, but I don't know if we want to... Like the render texture should still be okay. Where do you want to change it? Terrain patch. So we're talking about here. -1, 1. Yeah, now we need the offset as well. Now we're located in the middle at least. That's good. But like I'm still wondering. It feels weird. That does mean your grids though are actually res -1. The grid and the res, they are like organized like this so that each vertex is located in a grid center. And there is 128 entries. So, but I think you have 127 cells. I'm not. And 128 vertices. We can do it like this. Let's see if I can sell it in. So resolution 512 256 128. What do we have then? For 32. That's still too much. Accountable. Okay, so we don't do any subdivision. If we don't do any subdivision, we do resolution 4 times 4. Yeah, my shader currently doesn't really work that well with this. So we can do terrain debug shader. Let's do This one is hella weird. One sec. Environment subdivision 1. Okay, so this is with a setup of, we have a resolution of 4 totally for the full terrain, and we have a subdivision of 1, so we should be getting 2 times 2 terrain patches. We subdivide the resolution as well, so each terrain patch has 2 times 2. But we're not offsetting it here. Oh, I fucking hate this. So many times this resolution, vertex, etc. has been... Yeah, like, if we take a look at the environment, whatever we define here in resolution should be the number of data points each terrain patch has in each direction. So having resolution of 8 here has always been, and then we subdivide it, so we have 4 data points here. 1, 2, 3, 4. But you have 3 cells, 3 pixels in texture. No, yeah, it's confusing as fuck, but I don't think I have 3 pixels in a texture. We have 4 pixels here. It's just at the edges we have half pixels on the edges. That might be the confusing part. So each vertex has a separate pixel, basically. That's what we have. Vertices and center of pixels align, always. So pixel 0, 0, pixel 1, 0. That's quite confusing, but I kind of get it now. Yeah, it's just a different way of doing it. Is there a reason you can't just have a fixed res per patch? What do you mean? So like that we decide that each patch is 128 times 128 and never change it, or? So let me do this. What did we have here? We have 1028 2. Did we have this? Yep, as a field, so can change it, but it's how many cells a patch has. Ground truth, no subdivision constant. I mean, we could change our setup like that, but like this is just another way of doing it, I guess. Simplifies math, no -1 and no scaling in shader, etc. I'm not so sure about that. It feels like I've gone through this, the way this is structured, so many times, but like it's still a bit confusing. If we have a texture, if we think of each patch as a texture, so each patch, no, don't. I'm just saying that, like, it is confusing. I've gone through it so many times and I'm still not entirely sure how to describe it, but what I'm trying to think around is, I'm always trying to think about my terrain patches as textures, because that's basically what they are in the end. Resolution here, this one tells us how big a resolution should the full terrain base be. So if we don't have any subdivision, we get one terrain patch that is 512 times 512. If and this is without the duplication taken into account. But let's just say, so I can pretty much define here. So if I want 2 times 2 terrain patches and each terrain patch to be 128 times 128 pixels, then I just set subdivision to 1 and 256 here. So we just divide 256. Now we get 2 times 2 patches. Each patch is 128 times 128. And that's how I decide it. And when I say that each patch is 128 times 128, each patch is described by a texture that has 128 times 128 pixels. And that's just how I try to think about it at all times. So if we take a look at this one then, so if I would have written resolution 4 here, we would be getting this for each terrain patch. Or if I would have written 16 here right now, each terrain patch would be this, a texture of 4 times 4 pixels. And that's just the way I'm trying to think about these terrain patches at all time. And then when we do so this is where the mismatch, where the confusion happens. When we write the mesh here, I don't want my mesh to have a vertex here, 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 and here. Because that's wrong for me. I want my mesh to have a vertex here, 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 and here, basically. So I try to build the mesh so that each vertex in the mesh is located in the center of a pixel. Unfortunately, the UVs doesn't really take this into account, so this vertex has the UV of 0, 0, which means that if we try to read from the texture later on, we're going to read this point, even though we should be reading this. Harry O, you should be thinking of those things as cells. What should I be? I'm not really following. What should be cells here? So vertex 0 is still at 0, 0, right? So vertices 0 is still at 0, 0, right? But cell 0, 0 is at 0, 1, 2, 5. Let me just try and explain as well. Like, if we have the texture like this, the reason we do it like this is if we would have had it like this, like we would have vertices at the edges here, if we would have been reading from the texture later on, we would be getting a bilinear result of the 4 neighboring vertices, and I didn't want that. I wanted the result from the middle of the pixel. Like, basically the only mismatch we have in our right now is that when we generate the UVs for the mesh, we don't generate them with this in mind, and that's why we need to scale and offset the UVs eventually. In this example, and you have 5 times 5 vertices but 4 times 4, no I don't, not in this example. These are the vertices and this is the texture. Fucking hell, let me try and but then again, texture, vertices, but now I have to double check if this is the case. 16, 4 times 4. One, two, three, 4 cells. 1, 2, 3, 4 vertices. We always have as many vertices as we have cells. I think it's this half cell stuff that confuses stuff or makes it extra confusing. You have 3 cells. No, I have 4 cells here. 1, 2. You have 3 cells and 4 vertices. I don't think so. This right here, let's hide everything. The total chunk has 3 cells, 0.5 plus 1 plus 1 0.5. Yeah, but those are different. Like this cell is different from this cell. So this one right here is cell 0, 0, cell 1, 0, 2, 0, 3, 0. Right? So like this is one cell, this is one cell, this is one cell, this is one cell. Yeah, but your width is 3. Now I'm not... That means your resolution is 3. You have 3 pixels per chunk. No, we have... I'm pretty sure we have 4 pixels per chunk. We can do it like this. Ah, fuck, can I do it now? Maybe I've screwed it up too much. But we can actually do... let's see if we can do it like this. No, I can't currently. I don't mean unique points of information, I mean actual width. If you use your grid as a ruler. Oh, yeah. Okay, yeah. I get it. Okay, now I understand. Sorry, it's all very confusing. Vertices and pixels always align. Real, like units, length, width, I don't think... Yeah, so width is always... But width is decided by dimension here. You've got them in opposite way of standard. Resolution is the width, and image is 4 pixels, so your chunk should have 4 cells and 5 vertices to build a mesh. Yeah, that's the standard way. But if you have more vertices, than texture cells, then your vertices would be located in the middle or in between pixels. Wouldn't that be a little bit weird? So if we have this as height maps, if I change the height value in this pixel, then it's pretty straightforward then that it's this vertex that gets changed. But if we had one more vertex per width and height here, and I changed this height, then we would be changing this, and this vertex. That problem is unrelated. You can always shift by half whenever necessary. Yeah, so that's pretty much what we need to do now as well. I don't know. It's more so that your resolution is not the same as what you expect. I don't know. Maybe I'm possibly in the wrong here, but I like the fact that vertices aligns with pixel centers. You can align pixel with vertex centers in both methods. That's not the issue. Yeah, I'm still trying to figure out what the issue is. Or what you think the issue with this method is. It's just your resolution is currently resolution -1. I don't know if I'm misunderstanding you, but like the resolution of the textures aren't... the texture still has a resolution of resolution. Your resolution is currently resolution -1. What was the resolution of this map? Each terrain patch here is... so this one has a resolution of 16 × 16. It's a little bit of a mismatch here, though. Each chunk is one smaller than it should be. It's pretty much... we have this overlapping, so this one and this one, they describe the same data point as well. That's one other weird thing. So if we don't do any subdivision, we have 16. Then we have 16 × 16. One terrain patch, the terrain patch is 16 × 16 pixels. Or that's the resolution. 1 to 8 × 8. Now it's 15 wide. Oh, 1 sec. So if I do, what are you saying? If we do resolution 16 times 16. Okay, I'm trying to follow what you mean now. So here you're saying that we have, it's 15 wide. I get what you mean. So we have 16 cells, but it's 15 wide in units, because we have these half cells on the edges, right? That's your point. Each chunk is one too small. I get what you mean. But in actual resolution, like texture resolution, it's not too small. Well, now your texture should be res -1 though. I don't think so. Like 512 for 2. So in this case, I know that we have 4 times 4 patches. So we have a total of 16 patches. We subdivide 512 divided by 4, and each patch has its data is a resolution that is 128 times 128 in size. Like this is true. The resolution of the texture in this case is not 127 times 127. But if we compare it to like dimension, half of each is cut off on the sides, so you only have 127. So you only have 127. Yeah, I'm trying to wrap my head around this. I'm sorry if I'm slow here, but I actually have 128 times 128 distinct values in my texture. Yo, what's up, Harukanan? I don't know if it's that looking at one chunk in isolation. Yeah, I want to do it. Yes, but do you build your mesh with 128 times 128 vertices? Yes. I'm pretty sure 16 2 should leave us at 4 times 4 times 4. Okay, if so, let's see here. You're telling me draw a grid in Paint with 4 times 4 vertices. Four times 4 vertices. 1, 2, 3, 4. So something like this. Yeah, I think you guys are not understanding. I think you guys are not understanding actually. If we do it like this, so if we have an image that is, we represent this with a texture that is 3 times 3. If we try to read from the texture with the UV00 here, we get like, this is not how I structure my shit. So if you draw a grid with 4 times 4 vertices and you try to represent this with a texture, you align the texture with the vertices like this. That's why you get 3 times 3. If we were doing, okay, so if in our case we have something like this. So this is our vertices. This is our mesh. Our underlying texture here this is the underlying texture in our case. So this is how the current implementation is. So we have a grid, we have a mesh of 4 times 4 vertices, and we have a texture of 4 times 4 pixels. like initially, way back when we first wrote this terrain system, we actually always had one more vertex than resolution in texture. So everything you've been saying. But then I rewrote it such that we always have the same number of pixels as vertices. To align with vertices, you offset the UVs by 0.5 divided by resolution. Like the reason we have it like this is because the syncing between terrain patches was extremely easy to do like this. So if we do, if we have a resolution of 2 times 2, so we have a texture like this, we do it the way you guys are talking about. So we have 3 times 3 vertices like this. So now we always have one more vertex in each direction than resolution. And then we want to do, we offset by half a pixel then, because we want the vertices to be located in the center of the texture. So when we read, but the vertex is purely a mesh concept. Yes, that's why I've done it like this, because like when we set the height of this vertex, with this solution, we could either do a bilinear read from the texture, right? Or when we set the height of this vertex, the height of this texture could either be based on this, and this, or we could offset it by 0.5 to make it in the center of the pixels in the height map. So here. So then we read this height value for this one. But what do we do for these vertices? So when we want to set the height for this one, so if we isolate this patch, what we're actually seeing here is like the actual texture, underlying texture, is for height map, you would have the same as the height map res unless you are using patches, then you need to think about shared edges. But in that case, you should be adding 1, not subtracting 1. It all works in the end. Like, I do understand that this could seem confusing, but I don't really understand. Like, I honestly think this is a great idea. I think it's a great idea to sync vertices with pixel centers, basically. But if you're reading them without interpolation, then having it at center and bottom left makes no difference. Okay. So if we have it like this, and then we have a patch like this. These are two different patches. So in this case, we have two patches. Each patch is 3 × 3 vertices, but represented by a 2 × 2 texture. If we take a look at this vertex, so bottom left corner of this one, and this one. If we wanted to set the height of this vertex, we would be reading from you would set 2, 0. But okay, you would set 2, 0. But like, what UV should this vertex have? Which texture value should this vertex read from? Should it read from this one or this one or this one or this one? And if we do it like this, these are two different patches. This texture value and this texture value should be the same, which means that we now get 1, 2, 3 vertices in a line that has the same height, even though it should only need to be 2. Or am I thinking about it wrong? This one and this one. Okay, this one would read from this one from this one, this one from this one, this one from this one. This one from this one, this one from this one. What do we do with these then? We don't care about those, right? Or this one, this one. They don't exist, you only have 2 times 4. Yeah, these values don't exist, but these vertices exist. So this vertex, when we decide the height of this vertex, so we have, in this example, we have 4x2 pixels, but we have 5x3 vertices. Yes, vertices are only a mesh property, not a data property. Yes. Yeah. But like, when we set the height of these, or we just don't do it, or yeah, I get everything you say. It's just 2 different ways of doing the same thing. Like, we could probably do only worry about it when we construct it as well. The only thing we would need to do, actually, is the height of the top leftmost point will sample from 0, 1. 0, 1. Yeah. So this one will sample from the same as this one then. Difference is if the pixel is representing a face, /quad, or a vertex in the height map. Yes. In my case, it's a vertex. a pixel represents a vertex height. Pretty much. Would love to height map pixels are usually vertex height. Yeah. Harry-O, I would love to continue this, but I need to run now, unfortunately. I will be back on Monday, and hopefully we can finish this. Thank you so much for watching, everybody. Have a great weekend.